Alright, so I decided I would do a small video on fuel cut and fuel pump relay considerations for the MK3 Supra. I know there's a lot of write-ups out there about 12 volt mods for the fuel pump, and I've been studying the heck out of this circuit. This is taken from the Toyota service manual for 1987. I'm pretty sure the EFI system for all 7M GTEs are pretty much the same, if not identical. Um, let's start with basic operation. This here is the key switch, and right here is the fuse that's up under the hood there. Um, when the key switch gets turned on, you have current flowing through here. Now there's a couple of different ones. This is Canadian, and this is the American way that this goes. Apparently in Canada they don't believe in relays too much for the starters. So when you try to start it, you've got current passing through the circuit open relay. But if you look here, the actual fuel pump control relay that controls the pump is in a normally closed state for this contact, which should deliver straight 12 volts to the pump, because you see it's grounded here on the back panel somewhere. The other condition it can be in is when this relay actually picks up, then this switch moves over here, which goes through a resistor, and I believe it delivers about 9 volts right there. And I think the computer picks it up when it's idling. If you follow here, it goes to the computer. See fuel pump? I believe that's the pin that picks it up for idle and off boost conditions. Because just like the JZ engine, this engine is kind of dependent on fuel pressure to be in a certain level for certain areas of operation. So getting back to the 12 volt mod, looking at this diagram here, if you do nothing at all to this relay, it's going straight 12 volts to the fuel pump. The other thing too is when EFI is activated, which is picked up by the computer, you see here, main relay I believe is what MREL is, battery, again just like the JZ computer, this pin needs constant power, so that was my reasoning behind the chart I made in one of my previous videos. This one is controlled by the computer and actually picks up the main EFI relay. So here you got power coming this way, and that is the only way that the circuit opening relay can get power. But then again, the circuit opening relay, if you'll notice, has two different coils, alright? One coil seems to be controlled by the actual crank. I believe that's when you crank the engine over. Could even be when it's in the run position. But when you do that, you're also causing this one to pick up, and you're also causing this one to pick up. But just for a moment, if you notice, this relay has two coils in it. One is just a regular old coil, and one has got a capacitor and resistor across the coil. I believe that is a time constant relay coil, meaning it'll pick up for a certain amount of time and drop out. This one picks the relay up anytime there's power on it. And if you notice that one side of that coil goes straight to ground, again, somewhere on a set bolt on relay block number 4, which is also in this manual. Then the other side of that coil, if you follow that, it goes to the black and blue wire, which goes to the starter there. So that one is for when you're starting it. This one, I believe, is when you just turn the key to run. If you notice, when you turn your key to run, you'll hear the fuel pump run for a few seconds and then it shuts off. That is because the computer knows that it's not running. So when you look again at this time constant relay, you'll see that one wire goes back to the computer, FC, which I believe is fuel cut. Okay, so that's why I'm talking about fuel cut here. This green wire on B1 pin 6 comes from one side of the relay. Then you've got the EFI straight power once the computer picks this up. this is giving power to this relay. The only thing this relay needs now, clearly, is ground. So that green wire coming out on pin 6, if it's brought to ground, regardless of what this computer is doing, that's going to activate your fuel pump. And here's why. Because when this one's picked up, you're going to have power getting here. So now you got power on this side of this coil. All the other side needs is a connection to ground to pick up the circuit opening relay and go straight through your 12 volts, straight to the fuel pump, and straight to ground. Without getting into too much theory, anyone who's not clear on how relays work, you basically have a control circuit and you have a switching circuit. Most of the time, or well, very often, they're electrically isolated from each other. This is not the case because they can both use 12 volts DC, but sometimes you're switching with a different kind of voltage than you're controlling with. So relays have an electromagnet basically, and a switch that's attracted to the magnet to make it switch back and forth, right? If you look at all of this on a chart, on a wiring diagram, you're always seeing what the normal condition is, usually, meaning in the de-energized position. So normally closed, for example, would be this relay is in its normal state without power applied to it. When this electromagnet becomes energized, this switch switches over. So if you kind of get that. If you look at this diagram, once EFI is picked up, you got power coming here, and then all it needs again is a ground to here to turn the circuit opening relay closed and send power through to the fuel pump. So the circuit opening relay is there for safety, for your safety. Let's say we had this fuel pump running the whole time and you get into a wreck or something and the tank ruptures. Now you got a fuel pump spewing fuel all over the highway just waiting to explode. So, Toyota decided they needed that. Well, heck, just about anyone who designs cars now know that that's all in the name of safety. So whatever you do with this relay, bringing it to ground, you got to remember there's some kind of fail-safe that's got to come in. I also believe the computer, being called fuel cut, the computer is also monitoring things like overboost, too much air, not enough air. That's another way to save the car, is by opening this relay and killing power to the fuel pump. So anytime you're going to bypass a safety relay like this, I highly recommend you have a fail-safe put in place. One consideration would be to come up with another relay just like this, where the switching part is connecting this green wire to ground, but the pickup side, in other words the coil, could be, say, hooked up to the oil sender, maybe the oil pressure sensor. That way, if it's running, you got volts going to your coil because the oil sensor will deliver volts to the coil side. And then when the engine stops, no more voltage, right? So the relay opens. Alternatively, if you're on a racetrack and you have some kind of ESD or a shutdown switch and you're conscious of it all the time, you could just put a regular old toggle switch right there on that green wire and connect the other side of it anywhere to ground. That's going to pick up that circuit open relay, turn on the fuel pump relay, which is in its normal deactivated state going to give you straight 12 volts to ground. That eliminates having to put a whole other relay in there for straight 12 volts, when all you have to do is control this relay. I'm still kind of working on what I'm going to do with this in my particular situation. With this 2JZ GTE VVTi alphabet soup engine that I'm putting in the Supra. So I just wanted to share that with anybody who doesn't have access to this Toyota service manual. And I wanted to maybe get some feedback from anybody who's ever tried to do this and what anyone else might do in this situation. Because I've got a few thoughts about changing this time constant relay over to a timer circuit, a timer relay that I already have on hand. Really cheap stuff. You could actually dial it in to however many seconds you want it to run. And then the other way, I think I am going to use the oil sending unit. That way, if there's no oil pressure, then there's no fuel pressure either. So I hope that helped anybody. And again, I do videos like this because I don't find them anywhere. If anyone's got better information than this, please share it with me and share it with the rest of us, because I know the community would like to gain more knowledge on these things with the swaps and mods that we do with these cars. So anyway, have a nice day. Carry on. Drink a lot of coffee. Support your local coffee farmer.